A very good evening, everybody. Welcome back. Welcome back after a weekend of, I'm assuming, some amount of merrymaking and a great amount of getting ready for your future. That is becoming a data scientist. Because if you aren't keen on becoming a data scientist, you won't be part of this session. All right. And if you're part of this session, you should be focused even on your weekends. So, welcome back. One day rest is important. So, Sunday is good enough. As we had discussed last weekend, last week, we were discussing predominantly about an overview of all the supervised, unsupervised techniques and how supervised and unsupervised interact with each other, the choice of various algorithms, excuse me, etc. All right, at a high level. And then we wrapped it up with a nice recap last Friday. So what we are planning to do is go deep. We are going to peel the onion, keep peeling the onion back, and get into the depths of it. All right. And that is how you can expect in the real world the interviewers to be grilling you into a great detail. So we'll start with unsupervised, and in unsupervised, we are already very much clear about the clustering. We've also discussed about clustering, not just the usual hierarchical and non-hierarchical, but also the other 2-3 varieties of clustering we've discussed at great length, considerable length, I would say, on those things. So the next thing that we are going to discuss is something many data scientists do not pay importance, and good amount of people are not even aware that such a thing exists. All right. They assume that improving the model is only for supervised learning. Unsupervised learning is you build one model, done. My job is done. What did you do? I did k-means clustering. Okay, then what next? That's it. After that, I moved. How did you improve? No, why to improve k-means clustering? I've actually had people respond back. In unsupervised, there is no requirement for, they were very confident that in unsupervised, there is no necessity for improving the model. And that it is that aspect that we are going to be discussing today. All right. So I'll keep it very generic, the first question. So to you, Sharat, how do you measure the quality of a model with reference to clustering? And once you have measured it, how do you go to the next level? Could you please, brighten our day with your information on that?
Thank you, Nitin. Good evening, everyone. Good evening, all the participants joined with us. And good evening, everyone who's going to view it at a later point of time. Welcome to the channel. And let me jump into the question. The question is, how do we decide on the best clustering approach? The standard algorithms are anyways there, right? We've discussed about that. Hierarchical clustering, non-hierarchical clustering, then we have density-based clustering, right? So various other techniques are available. Each of this clustering technique has a specific objective. And that objective is to try and ensure that we get more and more homogeneous records being grouped together. Now, the idea is to ensure that the variation between the data points is minimized. If the variation is minimized, that means the characteristics with respect to those records will be similar. And when we talk about the characteristics being similar, that means the information is something that we will be able to extract. So clustering basically allows us to get this patterns understood from the data. Now, there are clustering evaluation techniques that we can use. And each of these evaluation techniques, of course, has their own methodology, the formulas, the background. Ultimately, all these things, all these techniques are trying to identify how good or how homogeneous are your clusters formed on your database, whatever the database that we are working on. There are certain techniques which we can obviously use. So for example, Sill-out coefficient. Then we have inertia score, which is very, very popular, which is used for by default, the technique used for k-means clustering. Then we have pseudo f-test that can be used. We have Dunn Index, Rand Index, so on and so forth. So these are various techniques which allow us to evaluate the clusters by doing quantification of the clusters. Okay.
Sorry. I was thinking I had done, my bad. So thank you, Sharath. Thank you for that detailed answer there. So anything you would like to add, Barney, on that with reference to any experiences you've had with reference to which metric you would prefer when you want to evaluate a cluster's quality?
Absolutely, Nitin. So a few of the metrics which can be used to evaluate clustering are classified as external and internal. External techniques are external validation metrics which are used to evaluate clustering success, whether clustering is good or bad, requires us to have the true labels, ground truth. Meaning, say you have done clustering and there is a new customer and you supplied it to your clustering algorithm, and your clustering algorithm puts that specific individual customer into, say, a cluster called as early adopters, people who adopt technology faster. So you put that person there. But does that individual truly belong to that cluster? If you can get that information, then, I mean, of course, it is difficult. It is not straightforward. You probably have to interview that person, right? Understand more details. And then you would probably figure out that, yes, this person will belong to early adopters cluster. If you know that ground label or ground truth using some mechanism experiments or using some kind of interviews, focused interviews, etc., then we have measures such as homogeneity, completeness, and you have something else which is called as V measure. These are the three metrics when it comes to evaluating cluster, provided you have the ground truth available. And all of these measures range between 0 to 1. Higher the values, better is accuracy, like 0% to 100%. And also, we have internal validation techniques, internal evaluation metrics, like silhouette coefficient is there. Then you have CH index, which our friend Sharath has spoken about. In that way, there are a lot of metrics which does not require you to have the ground truth values. Even without the ground truth, you can proceed further with the analysis or with the evaluation of the cluster. Not just this, there are also a lot of other criteria which one has to give importance to before deciding whether clustering solution is good or bad. There is something called as stability. With slight change in your algorithm hyperparameters, would one record will one record move into another cluster, or would it remain in the same cluster? Is it reliable or not? Okay, do you have clusters which are sufficiently large enough to say that, yes, this is a cluster? Okay, and reliable means only if there is stability, only if you know that, with certain changes in the hyperparameters, there is no significant change of records which belong to different clusters. Only then can you rely on that. Only then can you devise a marketing strategy around that. Okay, and it should be actionable. Whatever clusters you're forming, you should be in a position to take action upon that. You probably want to devise a marketing strategy for each of the segments or each of the clusters. Okay, and also the clusters should be relevant to the client's objectives. These are a few things which have to be given importance from business standpoint as well before we decide whether the cluster is good or bad. But at the end of the day, are you able to give logical names to the clusters or not? That would determine the success. And yep, thank you, Nitin. Yeah.
Thank you. So we have a couple of questions. One of them is my favorite because that is a question that I generally ask when I'm conducting the one-on-one mock interviews. Difference between k-means and k-nearest neighbor. All right. And this is a question. Let me just tell you the reason, and this is a very popular question, mind you. Reason why many interviewers ask this question, and initially in the first 3, 4, or 5 minutes of the technical round, they'll ask you this question, is to gauge how strongly rooted your concepts are. If you are going to K means K nearest neighbor, that is all. The interview is over. If you think even for a split second, you have to actually answer as if, what kind of a question is this? So K means is unsupervised, K nearest neighbor is supervised. That is a predictive method. This is a clustering method. These are totally different. They don't require the right answer. They require the way in which you answer the question. All right. So having asked this question, I've give you the answer. K-means clustering is an unsupervised method which helps us to identify the homogeneous clusters, and then subsequently, as Barney just mentioned, the success would depend on, after we have made the clusters, come up with certain labels for each of those clusters. K-nearest neighbor is a simple, shallow machine learning algorithm, supervised machine learning algorithm, which simply uses a distance measure for classification and in certain cases, prediction, or that is numerical prediction as well. That is a question. Like I said, please remember, not the answer, but how you answer it is a very popular question. Another question is how to find, I would ask Sharath to respond to this, how to find the ideal number of clusters in a data set, both in agglomerative and in k-means.
Yes, thank you, Nitin, for that question. Well, it is very subjective again. There will be a very, very, I should say, strong inclination towards the business requirements on how many clusters we need to choose on the given data set. But saying that, the algorithms have different approaches. These are designed, they are developed in different ways. Agglomerative clustering will allow us to take a subjective decision after we complete the hierarchy creation. That is, once the hierarchical clustering, which is agglomerative clustering predominantly, is done, we will be able to visualize the entire process using something called as a dendrogram, a visualization, a tree-like diagram. Using that, we will be able to take the decision. But again, this is more from a manual interpretation. The same way for k-means clustering, we basically look into something called as creep plot or elbow curve, which I was explaining in the last session, which tries to capture the inertia score, which is nothing but the homogeneity within the cluster. For different number of clusters, we'll try to identify how much homogeneity is something that we are able to obtain. Higher the homogeneity for a given cluster, better the cluster number. But at the same time, we also have automation function that can be used, which is called as cluster eval. Right? This is an algorithm which will allow the clustering techniques to automatically be evaluation is performed, tested, validated, you can say. And to do that, there are different parameters which the evaluation technique can take. The default one is the Sill-out technique, which is very popularly used, which ranges again from -1 to +1, but we consider the magnitude from 0 to 1. Stronger the magnitude, better the clustering exercise. Anything below 0 is very bad clusters. I mean, it is completely opposite from right, our objective. So that's the another function that we can use. It's called as clust eval. You can always go back and check the repository pypi.org for this package, and it has very comprehensive documentation which can help you to understand how automatically we can try and do the clustering, which also identifies the best number of clusters. Yeah.
All right. Thank you, Sharad. I think there's a follow-up question. We'll quickly address the question. Okay. My guess is on the basis of the questions that we are receiving, benefits and limitations of hierarchical and k-means clustering. Another person has asked what shallow means. I'm assuming that some of you have not completed your training, which is perfectly all right, and it's really commendable that you are trying to get into the advanced topics. Good, well done. So all these things would become clear with our training programs that we offer at 360 Digit MG. We have a plethora of training programs. If you are not a student, you can definitely try and get some more knowledge or get the information with our career guidance counselor, or watch our YouTube channel 360 Digit MG, wherein we have put in a lot of free content about these things. All right. Now, but nevertheless, having asked the question, I'll quickly respond to that. So, like I said, it depends on the approach. Everything has its own pluses and minuses. If there was something that was not good, we would have discarded it long back. All right. We don't use, the cathode ray tube monitors because it is not good. Simple. So, on that logic, everything has certain advantages. So, for smaller data sets wherein it is the visualization, you want to have a more interactive experience when you're doing the clustering process, you go for the hierarchical method. You know what is happening. You're able to see which data points are going there. You may decide to, even after that, manually say, no, you know what? While the hierarchy says it should be like this particular data point, I prefer there. 25, 30, 40, 50, 100 maybe data points which you can view is one thing. That is the advantage you have, which means if it is 500,000, 2,000, 20,000 records, you cannot even look at the hierarchy, and therefore the decision-making process cannot be done. So that is a disadvantage. So while the same thing is an advantage, it is also a disadvantage when you want to go for a bigger number. K-means clustering is more kind of, I would say, impersonal, and it's more suited for large data sets. It is relatively faster. All right, but then you really don't get the personal interaction. Where do you want to see the data points, how they are traveling, etc. So that's the benefits and limitations of both hierarchical and k-means. Shallow machine learnings are machine learning that has very little. Shallow is shallow water, deep water. So when you say deep learning, it goes into the depths, tries to learn more and more, tries to understand deeper into this thing, ask more questions. What if, what next kind of a things. And shallow machine learning is just understands very fundamental aspects of the data set and then tries to give the result, which may or may not be very good, or may not be able to reproduce it for the production data. So that is a shallow machine learning. Really interesting. We are having a lot of questions flowing in. So I think, Barney, could you please answer the question?
What is the question, Nitin?
One minute.
Ideal number of clusters?
Ideal number. Yeah, that was already answered. Somebody has repeated the question. Okay, my bad. I thought it was just jumping in, so that's already been answered. Thank you. Yeah.
But just to tell, we have elbow curve or spree plot. There is something called as gap statistic. And we have silhouette method. All these are used to determine the number of clusters. Yeah, but a number of clusters also depends on the domain knowledge, right? You need to interact with the customers. You need to interact and understand what business they are into and how many clusters really make sense for them. It's not something which is decided by us only based on statistics, but you also consider the domain aspect and then decide how many clusters actually make sense. Yeah.
All right. So moving along again in clustering, okay. We are talking about the hyperparameters that are there. So apart from K, which we choose to improve the clustering, we choose. I mean, that's something that we have discussed. Apart from that, where we choose the elbow curve may give you a K value, let us say 6. So we try maybe 4, 5, 6, 7, 8, and choose the best. Apart from that, are there any other things that we can tweak around in clustering? Question to Barney, please.
Okay. Yeah, absolutely, Nitin. So I would take example of probably hierarchical clustering, and try to help people understand a few things about that. When it comes to hierarchical clustering, we have different libraries using which you can accomplish hierarchical clustering. One is your SciPy, and another is scikit-learn or sklearn. Sklearn is something which people use extensively for any machine learning algorithm to be built. In this, we have a lot of hyperparameters. Hyperparameters are those options which can be changed so that you can experiment your algorithm with different options. For example, number of clusters. You can say number of clusters is 2 or 3 or 4 or 5 or 6, whatever. Of course, you get started with minimum 2 clusters, and the maximum number of clusters possible is equal to the number of data points. That means every individual customer would be treated as one different cluster. At the bare minimum, you should have at least 2 clusters, right? Otherwise, it doesn't make sense. You're not doing any clustering. If you say that entire group of customers belong to one segment, if you're making such a statement, then there is no clustering there. So number of clusters is one hyperparameter. Then we have something called as affinity. Affinity means distance. How do you calculate the distance? And K-means clustering or hierarchical clustering or majority of your clustering techniques majorly depend on distance in order to perform the underlying logic. We have Euclidean distance, which is also called as L2 norm. Then we have Manhattan distance, which is also called as L1 norm. Then we have Mahalanobis distance. We have cosine-based distance, and you have a lot of other distance measures. So we as data scientists have to experiment with different, distance measures and then figure out which one is better.
All right. Thank you so
Yeah.
much, Barney. Yeah. So one of the questions, the answer to one of the questions was talking about, after we do the clustering, the essential aspect is what next? You should be able to give those clusters some kind of labels. All right. So my question is, we are talking about unsupervised learning. So the unsupervised learning where we have the, the clustering happening. Once we have done that, which supervised algorithm or which prediction algorithm can be used, or what would you prefer for such a scenario? Question to Sharath, please.
Thank you, Nitin. Just to make this question more comprehensive, I would add a couple of more points based on the interactions that I have with various students. The question is if it is an unsupervised learning technique, then where is the question of prediction? Because The unsupervised learning techniques itself do not have any labels, and we don't do the algorithms for doing prediction of a specific variable. So what is the question of evaluating these algorithms in the first place? Right. So the answer for that question, and of course for the question that Nitin is asking here, is that the clustering exercise that we are doing is based on, any machine learning algorithms, right, for that matter, is based on historical data, and we're trying to group the data in clustering so that we get homogeneous records, homogeneous pair of groups, homogeneous pair of records grouped together. Now, when new data comes in, then how are you going to group the new data, right? So prediction in terms of grouping the new data or arranging the new data that is coming in into one of these groups that we have created from the historical data. That is the prediction that we are speaking about here. And the algorithms in clustering that we have, right? Almost all the clustering algorithms will allow us to do this prediction or arrangement of new records into the appropriate clusters, except for agglomerative clustering and hierarchical clustering technique, because it is purely a distance-based algorithm and it is arranging the data in hierarchy. So we cannot do prediction for new data, but apart from that, all the other algorithms can be used for classifying new data into appropriate clusters. And I also want to add another point here, probably taking another minute. With respect to the clustering, Bernie has rightly said that there are a lot of hyperparameters that we can keep changing. And remember one thing, every time we alter a parameter, whether it is a distance metric, whether it is the linkage functions that we have, or whether the number of iterations that we are doing, right? So everything that we are basically using as a hyperparameter will affect the outcome that we have. So again, we come back to evaluate the algorithm and see whether these set of hyperparameters are giving us the most homogeneous groups or not. Right? So it is an iterative process that we perform. We keep experimenting with new hyperparameters. We check the scores of the final clusters, and we see which of these hyperparameters are giving us the best scores, that is more homogeneous pair of records in each cluster. Nitin.
Thank you. Excellent. Thank you. That was, sewing a thread through all the beads that we have scattered out, and very beautifully both Barney and Sharath have connected, all the beads there, and we've done it. But yeah, we've got something, some more topics are there, because like I said, when you're a data scientist, when you have worked extensively on certain things, you get quite animated in the discussion, and then you probably try to get into more details, which is the objective, because that is what we want to. We want our participants to get a flavor of that. While you do not have the exposure of maybe 200, maybe 60, 70, 100 projects like Sharath Barney has, you definitely will get a taste of the discussion, people who have had that kind of project. So that is why we get into the details. So we'll be discussing little more about these, the hyperparameters for specific algorithms, in the next session, that is tomorrow's session. So this clustering topic with reference to hyperparameters is not complete. We'll be doing that as well as some other topics as well in tomorrow's discussion. On that note, we'd like to wrap it up. Once again, I find that a little disheartening, like I said, that the numbers are not increasing like we expected. All right, so please do advertise these events that we are conducting, not just the quiz, so the interview quiz that we are having at this point of time, but other sessions also that keep happening. Please advertise it far and wide, get more subscribers, and help us grow. And in the process, obviously, your knowledge is going to be increasing multifold. So on that note, thank you so much. Have a great evening ahead, and see you all tomorrow.
Yep. Thank you all so much, friends. Bye.
Bye, friends.